This is SpaceTime, Series 23, Episode 42. Coming up on SpaceTime. A new study shows plate tectonics on Earth is at least 3.2 billion years old. The Hubble Space Telescope celebrates 30 years of science. And the Sun's magnetic poles are reversing polarity, with 2 solar cycles now active at once. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has found that planet Earth was already experiencing plate tectonic movements 3.2 billion years ago, and that the plates back then were moving at similar rates to what they are now. The findings, reported in the journal Science Advances, adds new dimensions to the ongoing debate about exactly when plate tectonics first started on Earth, influencing the early evolution of the planet. Earth is the only known planetary body that has robustly established plate tectonics of any kind. Today, Earth's outer shell or lithosphere consists of roughly 15 rigid blocks of crust known as tectonic plates, upon which sit the planet's continents and oceans. The plates are moved by the convection of hot material rising up from deep in the mantle to the top of the lithosphere, usually at mid-ocean ridges. When molten basalts from these mid-ocean ridges reach the top of the crust, they cool down and solidify into the plates, which are then slowly pushed across the lithosphere by new upwelling material behind them until they reach the lighter granitic material which forms the continents. There, the heavier basalt subducts back down into the mantle, heating up the surrounding crust in the process and forming volcanic chains. Volcanic chains can also be formed from mantle plume hotspots, which remain stationary as tectonic plates slide above them, in the process providing a trace of the direction the plate's moving. This continuous movement of tectonic plates determines the sizes, shapes and locations of the continents, and it creates new mountain ranges. And together this combination of events influences atmospheric chemistry, global climate and even weather patterns. It also exposes new rocks to the atmosphere, which leads to chemical reactions that stabilize the Earth's surface over billions of years. And the planet's stable climate and surface has been crucial for the evolution of life. An enduring question in geology is exactly when Earth's tectonic plates first formed and began shaping the continents we see today. Some researchers think it happened more than 4 billion years ago, while others think it's far more recent, some just 1 billion years ago. The new findings are based on an analysis of magnetism in rocks from an ancient block of crust in the far north of Western Australia known as the East Pilbara Craton Honeyeater basalts. A craton is a primordial, thick and very stable piece of crust. They're usually found in the middle of tectonic plates and are the ancient hearts of the Earth's continents. And so this makes cratons a natural place to go study the early Earth. The Pilbara Craton stretches across about 500 kilometres and is one of the oldest blocks of stable crust on the surface of the planet. The rocks there have been dated to as early as 3.5 billion years. And these ancient igneous rocks retain a record of Earth's magnetic field at the time they formed, the time of their crystallization. To determine whether the lithospheric plates experienced any significant motion before the early Neo-Archean period, some 2.8 billion years ago, the authors extracted 235 drill core samples from the rocks to determine the orientation of the planet's magnetic field at the time the rock solidified. Earlier studies had already established the ages of the rock that crystallized at different times within the block. When combined with the direction of the planet's magnetic field at the time, it allows scientists to track the movement of the block over millions of years. They found evidence for a large change in the latitude of the block relative to the Earth's magnetic poles between 3.35 and 3.18 billion years ago, drifting at an average speed of around 2.5 centimeters per year, which is similar to plate movement rates observed today. The study's lead author, Alec Brenner from Harvard University, says the findings push back the date for the onset of modern plate tectonics into the late Paleoarchean. He says it looks like plate tectonics is a much more likely process to have occurred in the early Earth, and that argues for an Earth that looks a lot more similar to today than what a lot of people thought. This is SpaceTime. Still to come, the Hubble Space Telescope celebrates 30 years of science, and the Sun's magnetic poles reversing polarity, with 2 solar cycles now active at once. All that and much more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, ExpressVPN, rated number 1 by TechRadar. You may be wondering why you need a virtual private network. Well, it's in the name. It's all about privacy. Do you really want big brother tech companies, hackers, governments, and who knows who else snooping in on your online activities? Now, you might not have anything to hide, but it's still really creepy, and it could be dangerous for you and those you care about. Also, how often do you run across a website and you want to get information from it, but you find out that they're geo-blocked? It's all very frustrating, and it's becoming an increasing problem. And that's where ExpressVPN can help you. ExpressVPN's a simple and efficient way to protect your online privacy. It's internet without borders from the world's leading VPN provider. So, protect your online privacy today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more. And of course, you'll find the link details in the show notes and on our website. That's tryexpressvpn.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
With all the news about the ongoing COVID-19 coronavirus dominating the world's headlines, an important milestone in scientific history has been forgotten. The Hubble Space Telescope has just celebrated its 30th anniversary in orbit. It's hard to believe, but for more than a generation now, the Earth-orbiting observatory has been redefining our view of the universe, providing a new understanding of the cosmos and humanity's place in it. Hubble was launched aboard the Space Shuttle Discovery on STS-31 back on April the 24th, 1990, and deployed into a 569-kilometre high low Earth orbit. Named after the astronomer Edwin Hubble, the 11,110-kilogram school bus-sized optical telescope was part of NASA's Great Observatories project, designed to place specialist state-of-the-art telescopes in orbit, well clear of the distorting effects of Earth's atmosphere, from where they could provide astronomers with uninterrupted views of the heavens. As well as Hubble, which was observing in the optical, near-infrared and ultraviolet range, the other telescopes of NASA's Great Observatories project were the Compton Gamma Ray Observatory, the Chandra X-ray Telescope, and the Spitzer Infrared Space Telescope. Hubble used a 2.4-metre mirror. It was revolutionary, not just in the science it delivered, but also because of NASA's decision to design the telescope so that it could be upgraded and serviced in space. And that was a feature which would prove to be needed far sooner than expected, when mission managers received their first light from Hubble, only to find the images were blurry. Apparently, Hubble's main mirror had been ground incorrectly, resulting in a spherical aberration that compromised the telescope's capabilities. A servicing mission in 1993 fitted corrective lenses to the telescope to fix the issue. Over the years, a further 4 servicing missions have repaired worn-out systems and fitted new, upgraded instruments and equipment, the last in May 2009. From its sky-high vantage point, Hubble began opening a spectacular, never-before-seen window on the universe. So far, the telescope's yielded over 1.4 million observations and provided data which astronomers around the world have used to write more than 17,000 peer-reviewed scientific publications, making Hubble one of the most prolific scientific observatories in history. Hubble has helped astronomers determine the age of the universe. We now know that to be around 13.82 billion years. And it's helped to determine the rate at which the universe is expanding, a figure known as the Hubble constant. It's also shown us how that expansion is due to a force called dark energy, although we still don't know exactly what that is. Hubble has allowed humanity to look back in time, seeing the birth of some of the first galaxies after the Big Bang, and observing galactic evolution right up to the present day. Hubble has allowed astronomers to determine that essentially every galaxy in the universe has a supermassive black hole at its centre, and the bigger the galaxy, the bigger the central black hole, an association that astronomers are still grappling with. The orbiting observatory has studied the birth and death of stars, the creation of new planets, and it's seen some of the most distant objects in the universe. Hubble has allowed scientists to witness the gravitational lensing of distant galaxies by nearer foreground galaxies, thanks to the bending of light due to general relativity. Among its many spectacular images are the stunning pillars of creation in the Eagle Nebula, some 6.5 to 7,000 light-years away. Originally taken in 1995, the image shows towering columns stretching up to 4 light years in length, composed of clouds of molecular gas and dust, which are the birthplace of new generations of stars. The pillars have been eroded into their stunning shapes by ultraviolet radiation from recently formed nearby hot young stars. High-resolution optical and infrared images taken by Hubble in 2014 were even more spectacular, showing the pillars as ghostly sentinels marking the passage of time. But it seems time is not on their side. Although we can still see them, the pillars of creation actually no longer exist, having been blown away by the shock waves of a nearby supernova about 6,000 years ago. But because of their distance from Earth, it'll be another 500 to 1,000 years before the light of their destruction finally reaches the Earth. Another spectacular Hubble image is its ultra-deep field released in 2012, the deepest view ever taken of the cosmos. Hubble simply stared at a dark, seemingly empty patch of sky in the direction of the constellation Fornax. Instead of darkness, Hubble saw over 10,000 galaxies stretching back over 13 billion years, to a time when the universe was less than 1 billion years old. New Hubble observations of the same region in different wavelengths have revealed even more ancient galaxies, including one that appears to have formed just 450 million years after the Big Bang itself. Further, even deeper observations, combined with new processing technologies, have revealed that some of these very early galaxies are almost twice as big as expected. And that's raising new questions about galactic evolution during the period of reionization, a time when the very first stars began to shine. Hubble is still going strong, and NASA says it could last another 10, even 20 years. Its successor is the James Webb Space Telescope, and at this stage it's slated for launch aboard a European Space Agency Ariane 5 rocket from the Kourou spaceport in French Guiana in March 2021, forcing Hubble to share its spotlight for the first time. Mind you, Hubble isn't the only one of its kind in orbit. In fact, at least 22 space telescopes similar to Hubble, using the same basic design adopted for Hubble, have been built between 1976 and January last year. But unlike Hubble, which points towards the heavens, the other 21 were all Earth observation spy satellites, built for the National Reconnaissance Office, America's intelligence agency for space-based surveillance, and were designed to point not up, but down to the Earth's surface. They've gone by a variety of official names and code names, such as KH-11 Kennen, Crystal, Evolved Enhanced Crystal, 1010, Gambit, and Hexagon. But they're all generally referred to in the business as Keyhole. Over the years, there have been at least 6 basic technology upgrades known as blocks for the Keyhole series of space telescopes. And at least 2 of them, codenamed Misty, were even designed to be stealthy, virtually invisible to radar. The revelation that Hubble had at least 21 siblings came to light in 2012 when the National Reconnaissance Office donated a pair of Block 3 Keyhole spy satellites and spare parts to NASA, potentially for use as Hubble Space Telescope replacements. This pair were manufactured in the late 1990s and early 2000s and were originally meant to join the constellation of similar Keyhole surveillance satellites orbiting the Earth. But they were never used because the design had already been superseded by new Block 4 and Block 5 versions. Like Hubble, they were built by Lockheed Martin and equipped with 2.4-meter main mirrors and designed to orbit at a similar altitude. But because they looked down at the Earth's surface and not up, they were fitted with different optical ancillary equipment, and they also had a shorter focal length, giving them a wider field of view, about 100 times larger than Hubble's Wide-Field Camera 3 instrument. The 2 telescopes represent a multi-billion-dollar gift from the National Reconnaissance Office to NASA. But even so, they weren't complete, lacking among other things detectors, star trackers, prism wheels and filters. The good news is that they did come complete with bodies, mirrors, payload radiators, and 1.5-meter-long struts along the bottom for spacecraft instruments. One of them is now being rebuilt into a new Earth-orbiting space telescope called WFIRST, which will study the mysterious force of dark energy, which is sort of fitting considering the telescope's origins in the mysterious cloak-and-dagger world of espionage. WFIRST is expected to launch in 2024, filling the gap in space exploration between TESS, the successor to the planet-hunting Kepler Space Telescope, which is already up there in space, and Hubble's successor, the James Webb, which, as we mentioned earlier, will be launched next year. But for now, Hubble remains science's premier space-orbiting observatory. as this report from ESA TV explains.
Over 30 years, the Hubble Space Telescope has transformed astronomy. It's shown us images from the dawn of time, 13 billion years ago, and revealed an evolving universe that's not only expanding, but that expansion is accelerating. Hubble has witnessed the birth and death of stars and supermassive black holes at the heart of galaxies. But more than that, Hubble has influenced our culture, art and music. From posters and screensavers to T-shirts and rock albums, its colourful landscapes have given us a new perspective on the cosmos. The dream of a telescope above the distorting effects of the atmosphere goes back to the dawn of the space age. A joint mission between NASA and ESA, the Space Telescope was developed in the 1980s. It was named after Edwin Hubble, who discovered the universe was expanding. The size of an articulated lorry, Hubble was fitted with a 2.5-metre wide mirror. The European contribution included the faint object camera and the solar arrays, the telescope's power supply, designed to unfurl in space. Hubble left the Earth on April the 24th, 1990.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
The next day, the crew used the shuttle's robotic arm to deploy the telescope and release it into orbit.
Discovery, your go for umbilical disconnect.
Okay, we have a go for release, and we're going to be a minute late. Houston Discovery.
But within weeks, it was apparent that something was badly wrong. The mirror had been polished slightly too flat. At a sombre press conference, Hubble's program manager revealed the news.
Is that there's a significant spherical aberration appears to be present in the optics, in the optical telescope system optics.
Fortunately, Hubble had always been designed to be serviced.
This ability to service the telescope through human care will extend its lifespan up to 20 years.
On December the 4th, 1993, ESA astronaut Claude Nicollier used Space Shuttle Endeavour's robotic arm to capture the telescope in orbit.
Houston, Endeavour has a firm handshake with Mr. Hubble's telescope.
It was one of the most ambitious missions ever. Over 11 days, the shuttle crew carried out 5 back-to-back spacewalks. It included fitting an instrument to correct the telescope's optics and replacing the solar arrays. The mission would set the tone for future servicing expeditions, the last in 2009. Thanks to these upgrades, today, Hubble is in better shape than ever. Mission controllers hope it will last at least another 10 years, continuing its mission of discovery. At the last count, scientists have published more than 17,000 papers based on Hubble data. But perhaps more significantly, thanks to its amazing images, Hubble has given us a new sense of our place in the vast cosmos.
There's been more evidence that a new solar cycle is taking hold on the Sun, with magnetic map images from NASA's Solar Dynamics Observatory spacecraft showing 2 separate solar cycle sunspots on the solar disk at the same time. One of the sunspots, catalogued as AR2760, belongs to the old solar cycle 24, while just below and to the right is sunspot AR2761, which belongs to the new solar cycle 25. Scientists can tell they're from different solar cycles because of their opposite polarities. AR2760 is positive over negative, while AR2761 is negative over positive. Now, there's nothing strange about that. Solar cycles usually overlap during solar minimum, with further similar events expected over the next few months as the Sun slowly continues to push through what's become one of the longest and deepest solar minima in a century. Astronomers say 5 out of the 7 sunspots identified so far this year, that's 71%, have been from the new solar cycle 25. That compares to just 17% last year and none at all in 2018. The Sun goes through a roughly 11-year solar cycle, during which the polarity of its north and south poles flip. And it's during solar minimum that this reversal takes place. It's a time of little, if any, sunspot activity. However, as the new solar cycle takes over, sunspot activity will start to increase again as our local star climbs towards solar maximum. Solar max is a time of violent geomagnetic storms on the Sun, triggering intense solar flares and powerful coronal mass ejections, which can cause space weather events on Earth as energy and plasma slam into the planet, sparking colourful celestial light displays known as the aurora australis and aurora borealis, the southern and northern lights. However, radiation from these space weather events can also damage spacecraft, affect navigation and communication systems, decay the orbits of satellites, cause blackouts in terrestrial power grids, and increase radiation doses for astronauts and even airline crews and passengers on polar flights. This is SpaceTime. Still to come, the science report. Growing concerns of young and middle-aged people barely sick with COVID-19 dying of strokes. Oil and gas operations releasing the greenhouse gas methane at twice the average rate. And we look at the healthiest way to brew coffee. All that and more still to come on SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. China has threatened to boycott Australian exports if the Australian government continues its call for an independent inquiry into the origins and spread of the COVID-19 virus. The push for an independent investigation follows China's actions during the World Health Organization's inspection of the Wuhan province where the outbreak began, during which Beijing insisted that half of all inspectors be Chinese, appointed by the Communist government, and that they be allowed to undertake the final edit and approval of the report. That report, which praised China for its transparency and openness and its swift and efficient actions during the outbreak, has been ridiculed by doctors and journalists at the scene as a work of fiction unsupported by the facts. However, those same critics have since been arrested and disappeared, with some dying, allegedly, according to the Chinese government, from the disease. It's now widely known that the Chinese government hid the true extent of the outbreak and its ability to spread from human to human. Compounding the problem, Beijing banned travel from Wuhan to other parts of China, but continued to allow international travel from Wuhan to the rest of the world, spreading the deadly infection globally. Meanwhile, there are growing reports of young and middle-aged people barely sick with COVID-19 dying of strokes. Doctors sounded the alarm about patients in their 30s and 40s dying or left debilitated, some of whom didn't even know they were infected. In the vast majority of younger adults, COVID-19 appears to result in only mild illness, with the risk of more severe consequences rising with every decade of age. According to data from the Centers for Disease Control and Prevention, there's a 0.8% chance of deaths in people aged 25 to 34, a 2% chance among those aged 35 to 44, and a 5.4% chance among those aged 45 to 54. Meanwhile, a report on the pre-press medical website medRxiv has found intense testing in the small Italian town of Vo has turned up a large proportion of people with COVID-19 who have apparently no symptoms at all. Researchers swabbed almost every resident in the town for viral RNA and found that some 43% of people infected had no fever and no other symptoms. A new study warns that global insect populations have dropped 25% since 1990. The findings, reported in the journal Science, are based on a meta-study of 166 long-term surveys of insect populations across 1,676 sites. Researchers have found that land insect populations have declined by 9% per decade since at least the 1990s. At the same time, freshwater insect populations have increased, perhaps partially owing to clean water efforts. A new study warns that oil and gas operators in America's sprawling Permian Basin are releasing methane into the atmosphere at twice the average rates found in previous studies of 11 other major U.S. oil and gas regions. The new findings, reported in the journal Science Advances, are the highest emissions ever measured for any major U.S. oil and gas basin. In fact, scientists found so much methane escaping from their Permian oil and gas operations that it nearly triples the 20-year climate impact of the burning of all the gas they're producing. Based on 11 months of satellite data, encompassing some 200,000 individual readings taken across the 160,000 square kilometre basin, the Permian oil and gas operations are losing methane at a rate equal to 3.7% of their total gas production. That wasted methane, which is the main component of natural gas, is enough to supply 2 million US households. Methane is one of the most potent known greenhouse gases, human emissions of which are causing over a quarter of today's global warming. A report in the European Journal of Preventive Cardiology, looking at 500,000 people from Sweden and Norway, has found that the healthiest way to brew coffee is to use a filter. That's because the filters can remove substances in coffee beans that increase blood cholesterol. The researchers found drinking filtered coffee was associated with a reduced risk of death compared to people who drank no coffee at all. But unfiltered coffee was associated with an increased risk of death from heart problems in men over the age of 60. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.